So continuing with this idea of projectile motion, because we are looking at this simplified one where there is no air resistance, and we know that it's going to be a parabola, we can take advantage of that. So sometimes maybe we don't need to use vectors. Sometimes we can just use our knowledge of the quadratic function. Right? So they were the equations that we came up with, but essentially what we've got are parametric coordinates. Look at the x value, vt cos theta, y is vt sine theta minus half gt squared, t being the parameter. I could then create a Cartesian equation for that parabola. Make t the subject, we get t equals x on v cos theta, sub it into the y value, and I've got a quadratic. I mean, I can play around with that and tidy it up a bit, and then end up with something like that, but we can get a quadratic equation. So back to those common questions then. If I know the equation and I said, well, what's the range of the particle? Well, that's going to be the roots of the quadratic, the solutions to the equation. I could, again, I've got it in that form. If I wanted to find the roots of that, let's factorise, and eventually we get two possibilities, x equals 0, but that's where we launched it from, and the other one therefore must be the range. And tidying that up, there it is, v squared on g sine 2 theta. The greatest height of the particle, well, that's when we said that y dash was equal to 0, but the greatest height must be the vertex of the parabola. And if all I'm interested in is the y value, then I can use that idea of minus the discriminant on 4a just to get that value. So substituting that in and playing around with that, there we go, v squared sine squared theta on 2g. That would give me the greatest height. If I wanted to find out what angle it makes with the ground, or at any other point for that matter, well, now I'm talking about the slope of the tangent to the curve. So I can find that slope, and remember slope equals tan theta, and then that would allow me to find the angle that it makes with the ground. So let's look at that same example that we did yesterday, but using these ideas. Of course, I didn't have this question in there yesterday, but let's find that Cartesian equation. So we came up with x equals 20t, make t the subject, substituted it into the y component, and I've got a quadratic equation to play with. The greatest height, right? Y value of the vertex. Sub it into the minus discriminant on 4a, and there it is, 45 on 4. Same answer, of course, that we got yesterday. The range, okay, let's go and solve the equation, and we get our two answers. X is 0 or 60. 60 was the range. Velocity and direction after half a second. Okay, there's the equation. I want to find the slope of the tangent, so I'll differentiate it. T equals a half, but I need to know the x value, so I'll substitute into the x equation, and we get x is 10. So from that, I've got that the derivative is a half, the tan theta is a half, there's that angle we came up with, 26 degrees, 34. The actual velocity, I can go back to the parametric, I guess, v equals x on t cos theta, and substitute in that. So create our triangle, because we know tan theta is a half, sub all that in, and we've got 10 root 5. So as I said, it was going to be quick, but it could be useful sometimes just to use the knowledge of the parabola. Could be quicker. Another approach to it.